Somewhere above your head tonight, a spiral galaxy is turning the wrong way. Not by chance, maybe. By design. Astronomers sorted hundreds of galaxies from the deepest James Webb field ever taken by spin direction, and found the exact fingerprint you would expect if our universe really is inside a black hole. A second team ran the same test and got the opposite answer. Is our universe inside a black hole? That fight is still going right now in peer review. Here's the coincidence that started all of this. Take the estimated mass of the observable universe and run it through the Schwarzschild radius formula, the same equation that defines a black hole's event horizon. The number that falls out lands almost exactly on the size of the observable universe. Physicists have known this since the 1970s. It's a striking match. It is not proof. Two numbers landing close together doesn't mean one caused the other. And for decades, this stayed a curiosity, a napkin math trick, pulled out at conferences, never a real testable hypothesis. What changed it was a mechanism, not just numbers matching, but an actual claim about what a black hole could give birth to, and what fingerprint that birth would leave behind. Physicist Nikodem Poplawski built that mechanism. In his model, general relativity gets a small addition called torsion, a twist woven into the geometry of space-time itself. Feed enough mass into a black hole, and instead of crushing down to an infinitely dense point, torsion pushes back. Collapse reverses into expansion. A new space-time opens on the far side of the horizon, sealed off from its parent, with that horizon now playing the role of the parent universe's own Big Bang. That's the piece the standard picture never explains. The usual story starts with a hot, dense point and expansion, full stop. It never says why. This gives the bang a cause. Here's the part that matters most. A black hole can only pass on two properties to whatever forms inside it: mass and spin. Nothing else survives the crossing. If our universe really formed this way, it wouldn't just inherit its size from the black hole that made it. It would inherit that black hole's rotation. Every galaxy seeded from the same collapsing spin should carry a faint statistical bias, leaning one direction slightly more than the other. Not forced on any single galaxy, not obvious one at a time, but there, if you count enough of them across enough of the sky. And yes, that means the black holes sitting inside our own galaxy right now, the ones astronomers photograph and weigh, would be doing the same thing on a smaller scale, each one sealing off its own pocket of expanding space-time, invisible to us, undetectable from the outside forever. Universes inside universes, not as a metaphor, but as a literal, mechanical consequence of the same equations. Nobody has to invoke anything mystical for that. It falls straight out of the torsion math. Someone already went looking for the fingerprint. Back in 2011, physicist Michael Longo catalogued 15,158 spiral galaxies from the Sloan survey and found 7% more spinning counterclockwise toward the Milky Way's North Pole, an effect stretching past 600 million light-years, with odds of roughly 1 in a million for it to be an accident. Stranger still, that asymmetry's axis lined up with a separate, unexplained pattern in the cosmic microwave background one astronomers had already nicknamed the axis of evil. Two completely different measurements of the infant universe, pointing the same way. It looked like confirmation. Then a follow-up study pushed the search out to 3.5 billion light-years, and the signal all but disappeared into the noise. Fast forward to February 2025. Astronomer Leo Shamir went looking again, this time in James Webb's Jade's Deep Field, one of the sharpest views of the early universe ever captured. He classified 263 spiral galaxies by spin and found roughly 50% more rotating opposite to the Milky Way than with it. Not a coin flip, a lean. He checked older Hubble data covering the same patch of sky. Same lean, independently, and the deeper the field, meaning the further back in time, the stronger that lean got. That's exactly the signature a rotating early universe should leave. Faint nearby, sharper the closer you look toward the beginning. Then again, the pushback. A separate team ran a far larger, independent reanalysis, pulling from multiple surveys and multiple telescope systems, and reported no significant dipole at all. Statistically isotropic, exactly what a non-rotating universe should look like. Princeton astrophysicist Netta Bachal raised a simpler objection. Local gravity, dust lanes, and the Milky Way's own pull on nearby galaxies could fake a directional signal with nothing cosmological behind it at all. Shamir answered back with his own reproducibility paper, arguing several of those null results depended on hidden methodology choices that, once corrected, quietly buried the same lean he kept finding. Neither side has backed down. The datasets are still small, a few hundred galaxies here, tens of thousands there, set against trillions of galaxies across the observable universe. And that argument is the actual point of this story. A theory that predicts nothing checkable is just philosophy dressed up in equations. Black hole cosmology predicts something specific and falsifiable, a measurable, growing spin bias in the deepest galaxies we can see, one that should sharpen with every deeper field. That prediction can fail outright. That's what separates it from every other version of this idea, built purely on the Schwarzschild size coincidence, which was never checkable to begin with. Every new James Webb deep field adds more galaxies to the count. Every recount either strengthens the lean toward one direction or erases it for good. Within a few years, this specific question should have a real answer. Not because someone spotted a shape in the microwave background that looked meaningful, and not because two numbers happened to match, because the sample finally got large enough to stop arguing about noise and start arguing about facts. That sample is already on its way. The Vera Rubin Observatory in Chile began its 10-year survey of the southern sky in 2026, and by the time it finishes, it will have catalogued roughly 20 billion galaxies, a number that makes Shamir's 263 look like a rounding error. Somewhere in that flood of data sits the answer to whether the early universe had a preferred spin, buried in statistics too large for either side to dismiss as a fluke or a methodology quirk. For the first time, this stops being a fight between two small datasets and becomes a question with enough evidence to actually settle it. And if it settles in Poplawski's favour, the consequences don't stop at galaxy counts. It would mean the Big Bang wasn't a beginning out of nothing, but a doorway out of something else's collapse. It would mean every black hole quietly orbiting inside the Milky Way right now is doing, on a smaller scale, exactly what made us. Not a metaphor, a mechanism, sitting there in the torsion equations waiting on 20 billion galaxies to confirm or kill it.